If you're someone who procrastinates a lot, no matter how hard you try, but you cannot get things done, then listen to me for the next 1 minute. I'm going to share with you the 3 most important things about
Ariane-6 joins Europe's fleet of rockets for independent access to space. Building on the design and knowledge of 5 decades of Ariane launches, Ariane-6 will be versatile, modular, European. Ariane-6 comes in 2 versions that together can launch any type of satellite and mission into orbits around our home planet, to the moon, and beyond. Ariane-6 has 4 main sections. The boosters provide an enormous push early on to escape Earth's gravity. Depending on the power needed, Ariane can be fitted with 2 boosters or 4. They burn for about 2 minutes and then are ejected. The main stage, powered by the mighty Vulcan 2.1 engine, provides part of Ariane-6's thrust. It ignites with the boosters, but continues to fire for almost 8 minutes until the rocket is out of Earth's atmosphere. The upper stage kicks in next, powered by the restartable Vinci engine. It can fire at will to bring multiple satellites to different orbits, as well as returning to Earth for safe disposal, minimizing space debris. The fairing sits at the top of the rocket, like a hat, to protect the satellite or passenger inside. From ignition to orbit takes just 8 minutes. 5, 4, 3, 2, 1, liftoff. The solid fuel boosters burn fast and separate first, making Ariane-6 lighter and the voyage to space easier. Once past Earth's atmosphere, the fairing is not needed to protect the spacecraft, so it is jettisoned. The main engine stops running after about 8 minutes and then separates from the launcher. Ariane-6's upper stage now takes over to reach orbit and precision placement of the satellites. The upper stage makes it possible for multiple satellites to be delivered into different orbits. It can be turned off and restarted in space, even saving enough fuel to return to Earth for a clean disposal, burning up in our atmosphere and limiting space debris. Thirteen countries contribute to Ariane-6, and components for the rocket have been designed and constructed by companies all over Europe. 4 organizations take care of the Ariane-6 program. ESA is the head of the program. It manages the budget and is in charge of the overall launch system. Ariane Group is the main contractor and has designed the Ariane-6 rocket. It orders and ensures the delivery of components from production facilities across Europe. Its modern and operational approach is based on its expertise from Ariane 5. France's space agency, CNES, designed and built the Ariane-6 launch pad at Europe's spaceport in French Guiana, managing operations, ensuring range safety, and tracking the launch. ArianeSpace's sells the Ariane launches, negotiating with and accompanying companies and public organizations to launch their products into space. The trip to space starts in mainland Europe, with companies delivering thousands of precision components needed to build a rocket. The Ariane-6 stages are shipped to Europe's spaceport by the unique Canopé ship that can make a round trip every month to Europe's spaceport in Kourou, French Guiana, and reduce transport costs by half. Sails on the ship will reduce emissions by up to 30%. Europe's spaceport is near the equator, so rockets get a boost from Earth's rotation, the ideal place to launch to the stars. Integration of the Ariane stages starts on arrival at the spaceport, where the rocket is built. Just hours before launch, the mobile gantry rolls away to give Ariane-6 a clear view of its destination, the stars. From design to liftoff, thousands of Europeans contribute to the Ariane adventure, launching space missions to explore and benefit from our universe. Involved.
Imagining Ariane-6. Imagining a heavy lift launcher. That's an immensely complex challenge. Weight, performance, power, payload capacity, etc. Everything has to be optimized with extreme precision to meet extreme conditions. For instance, the use of liquid propellants at super low temperatures. Or the thinness of the central core's aluminum casting. Less than a centimeter thick, it must be able to withstand the rigors of spaceflight. Ariane-6 is a symbol of robustness and reliability, with over 600 companies, including more than 300 SMEs, involved in its design and production. It's a truly European endeavor. Behind this cooperative effort lies a huge challenge, coordinating all the expertise, managing the huge range of partners and manufacturers so that every stakeholder can contribute their unique know-how to the project. That's what European space engineering is all about. This rocket takes shape all across Europe. The launcher's propulsion systems are built in Vernon, France. Les Mureaux provides the main stage. The high-temperature protective structures and booster propulsion systems are designed and made in Bordeaux. The fairing is integrated at Europe's spaceport in Kourou, French Guiana, and the upper stage is manufactured in Bremen, Germany. Each partner plays their role in making Ariane-6 a uniquely capable, perfectly optimized, high-performance heavy-lift launcher. All the components then arrive at Europe's spaceport in French Guiana. This is where the launcher undergoes final assembly. Every millimeter matters, and this process is carried out with absolute precision. Ariane-6 stands ready on the launch pad, ready to write a new chapter in European space.
And there she is on the pad, 11 minutes and 41 seconds to launch. And the teams here in the fishbowl, what we call the fishbowl inside that glass, some of the teams from ArianeSpace and Ariane Group who are responsible for our rocket. There they are. We call this group the flight desk, David.
Yes, here we have the CEO and CTO of ArianeSpace. We also have Ralf Stucker, who is precisely the head of launcher exploitation at Ariane Group, so in charge of delivering and building the launcher here in French Guiana. Yep, very important job. Boards are green there. You can see them on the panels. We have a number of control rooms on the job today, some in Europe. We have two here in the Space Centre. We've got mission control we've been looking at in charge of the mission, and closer to the pad is launch control. What are these folk doing, David? Yes, this is the CDL-3. This is the place where the teams are getting the launch pad and the rocket ready for liftoff. These are the operations team. They are sending the various commands to turn the launcher avionics on, to fill the propellant tanks, to pressurize the tanks, and to do all the necessary checks to confirm that the launcher is ready for launch. And behind them, behind the glass windows in the back, the engineering teams are monitoring all these operations closely, making sure that all parameters are as expected. They are following all physical parameters, temperatures, pressures, electrical currents. And all these teams are also being supported in Europe by some additional teams who are there to help in case of need.
The more the merrier. Always good to have lots of people on the job. We had the final weather check about 10 seconds ago at T-10. The weather board is green, so that's good news. Obviously, weather conditions must be right for a launch to go ahead. And we are, of course, in the Amazon rainforest, on the edge of the Amazon rainforest here on the coast of French Guiana, so it obviously does rain a lot, but rain isn't a problem, although there are other things we need to monitor, aren't there?
Yes, that's right. We monitor high altitude winds between 10 and 20 kilometers. We need to make sure that wind speed and direction are below a certain limit, not because the launcher could not withstand it, but for safety reasons in case of any launcher malfunction. And we also monitor lightning risk during the ascent to avoid being hit by lightning, of course. Here on the ground, we have the launch mast, the lightning mast that you see in the images here, so we are protected.
You can see here the weather center at the base.
That's right, and from here we launch the weather balloons that you see here. They are sent up into the atmosphere with sensors to capture atmospheric temperature, pressure, humidity, and from this we are able to predict precisely what the conditions would be for launch.
I've had another question coming in from Patasensa. What's the difference between the Ariane-6 and 6 version?
Yes, so we have two versions of Ariane-6 with either 2 or 4 boosters, depending on the launcher performance that we require for the mission. Today, we only need 2, considering the satellite mass and the targeted orbit.
Now, teams have been working here at the base preparing the rocket and the satellite now for some weeks. We call that process the launch campaign. Just talk us through some of the events, some of the things they've been doing, David.
Yes, so here you see Canopé, which is the new cargo ship, a hybrid using sails, that has transported the rocket stages from mainland Europe to French Guiana. They arrived here end of November, and they were then transported by road to the horizontal assembly building that you see here. In this building, the main stage and the upper stage are mated together. We do the physical, the mechanical connections between the 2 stages, and afterwards the electrical connections. And once this is ready, the whole core stage is transported to the launch pad. There is 800 meters, and we use this automatic vehicle to transport the stage to the launch pad. We are then lifting it up and putting it on the launch table, from which it will take off. The boosters are added to the launcher to complete the assembly of the launcher. On the satellite side, CSO-3 arrived by plane to French Guiana. It was mid-January. It was then transported to the satellite preparation facilities, where it was checked, it was fueled. And once all of this was ready, it was integrated on the satellite adapter, which is the interface between the satellite and the launcher. And this was then integrated into what we call the LVA, the launch vehicle adapter, on which we bring the 2 fairing halves to encapsulate the satellite inside and get it ready for its transport from this encapsulation building up to the launch pad. And once we get to the launch pad, that was just a few days ago, we put it on top of the launcher, and we do the final integration of the satellite on the launcher and to get it ready for launch.
Indeed, so many operations, lots of experts working there, bringing us to this point, 5 minutes and 48 seconds now to launch. But actually, the final countdown started around about 10 hours ago. There were a lot of operations during that time, weren't there?
Yes, the countdown started a few hours ago with the mobile gantry rollback very early this morning, 8.5 hours before launch. After that, all the propellant lines were flushed and cooled, and then the fueling of the launcher started around 5.5 hours before launch. And in parallel, we had electrical checks and arming of the launcher in preparation for the launch.
À tous les DDO, attention pour la séquence finale lanceur. 0-5 minutes.
And the Range Operations Manager, Alex Serk, has announced the beginning of what we call the synchronized sequence, or the automated sequence, or automatic sequence. Ariane 6 is now becoming progressively autonomous. And again, a whole range of very vital operations now during this time, David.
Yes, all those operations are very precisely timed, combining system checks, pressurization of the cryotanks, activation of different systems and valves. And the control of the operations is gradually being handed over from the ground computers to the onboard computers. These onboard computers will actually send the last commands to ignite the main engine to check that it's working properly, and then it will command the opening of the cryogenic arms and the ignition of the boosters just before liftoff.
Those are those yellow arms you can see up there attaching to the rocket. And as we said, we've got a number of different control rooms on the job, and some of those in Europe. This is the team at Evry, ArianeSpace team in Paris.
Yes, this is headquarters in Paris. Lots of people that have worked in the preparation of this launch.
Hello, everybody. Looking forward to the launch there. We've also got one of the Ariane Group sites in Ottobrunn in Germany.
Yes, this is Ariane Group's European Center of Excellence for the development and production of rocket engine combustion chambers.
Go Ariane. Lots of support from there. And let's say hello now. Hello to everybody in Bordeaux, in France, another Ariane Group site.
Yes, there are several Ariane Group sites in this region in charge of booster engineering and the preparation of booster parts and high-temperature materials.
Fantastic. Everyone showing all their support there. Go Ariane 6. So, 3 minutes and 5 seconds now as we get closer to launch. Some excitement there in the various different centres, but we've got some very high concentration levels back here at the Guiana Space Centre, where we're getting very close now. A couple of things to look out for, David. Now, if you look at the two-thirds up the rocket, you can see what we call the cryogenic arms. We saw them briefly earlier. What are they doing? They're pumping cryogenic fuel into
That's right. They're pumping liquid oxygen and hydrogen into the tanks of the upper stage. They're very cold. Liquid hydrogen is minus 253 degrees Celsius. You can see them better here in this image. And oxygen is 180 degrees below zero. And yes, they are very, very cold.
Yeah, and you can't see it here, but sometimes you can see a little bit of white smoke coming out. So actually, this is the Vulcan engine we're looking at right now, the engine on the main stage. And we have an ignition sequence, don't we, David, which involves it switching on 7 seconds
That's
before.
right. That's right. The engine will be switched off 7 seconds before liftoff. The onboard computer will check that everything is working correctly. And so once that is done, it will send the commands to open the cryogenic arms and to ignite the boosters. Once that is done, there is no holding back.
Yep, our rocket will take off. Yes, so people here in the Mission Control Center now sort of heading out, because a lot of people like to go onto the balconies to watch the launch with their own eyes. So you can see in here in Mission Control all the VIP seats, all the guest seats are empty. The boards are green. We are getting close now to launch.
À tous les DDO, attention pour moins d'une minute. Top à 0-1 minute.
We are 1 minute to launch. Best wishes now to all the teams who have been working so hard for today. Good luck, everyone.
Bon voyage, CSO-3 on Ariane 6.
À tous les DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale. Pilotage calme.
We have lifted off. Ariane-6 and CSO-3 have started their
Propulsion
journey.
nominale.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à
looking
bord sont
down.
nominaux.
He's telling us that everything is going normally. I believe, David, we're looking down here at one of the boosters.
Yes, that's right. These are the onboard cameras. We have a
Propulsion
cloudy day
nominale.
today, so you can see the rocket going through the clouds.
Indeed, we've already broken the sound barrier. We
Pilotage
have,
calme, trajectoire nominale, paramètres à bord nominaux.
he's telling us that everything's going according to plan. David, we can hear our rocket coming over the Jupiter Mission Control Center, about 16 kilometers from that pad. It takes time for the noise to get to us, the rumble, as it's sometimes known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15
propulsion est
kilometers
nominale.
away.
Indeed, and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters, well, their job is to literally boost us away from our
Trajectoire nominale,
planet's
paramètres à
gravity.
bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of
Pilotage calme.
propellant during a bit more than 2 minutes. And after that, we will have lost about 70% of the mass that we had at the time of liftoff.
That's the name of the game. The lighter we are, of course, the faster we go. Those boosters scheduled to
Propulsion nominale.
detach in a matter of seconds. Seeing our images here on the live cameras
Séparation des ESR.
just a few seconds after the event, but we have confirmation that those have actually separated. As I
Propulsion
said,
nominale.
the images are coming to us for technical reasons, just with a very slight delay. And he's telling us that the propulsion is nominal. And there we go. That's what it looks like in space. Those boosters falling away. The trajectory on the right-hand side of our screen. the
Trajectoire
green-
nominale, paramètres à bord sont nominaux.
Everything's normal. The green line is the planned trajectory. The cross, indeed, is our actual position of our rocket. Our speed and altitude. David?
Yes, we are close to 100 kilometers now, and we're 150
La propulsion
kilometers
est nominale.
downrange from Kourou, and we have a speed now of 1.7 kilometers per second and increasing.
Per second, not
Per
per
second.
hour, per second. So that's the kind of speeds we're going to be heading up towards. We'll be getting to 8 kilometers per second. Look at the images on the bottom right of your screen. That is the big main stage, the tank of fuel at the very front of sort of pointy section, if you like, is our fairing with our satellite inside. It's got a number of
Propulsion
different
nominale.
jobs. It's protecting the satellite, isn't it?
Right, it protects the satellite while it's on the ground against dust,
Pilotage calme.
humidity, on any kind of pollution. Then it protects the satellite during the launch itself, the liftoff, because there is a lot of acoustic noise.
Trajectoire nominale.
And finally, during the atmosphere part, then it protects it against the air friction and the extreme heat that is generated by this friction.
So our satellite nice and comfortable up there in first class inside the fairing, having started its journey. That fairing will remain there for another few seconds. And of course, as we saw earlier, David, you were explaining it's made in 2 halves.
Look CNES, agence spatiale française, assure par délégation de la Direction générale de l'armement la maîtrise d'ouvrage du projet CSO. Cela va de la conception du système satellite jusqu'à sa mise en orbite et son exploitation opérationnelle pendant toute sa durée.
La trajectoire est nominale,
Pour cela,
tous les paramètres à bord sont nominaux.
Des compétences métiers pointues et un savoir-faire reconnu depuis 35 ans. C'est au CNES que sont opérés quotidiennement les satellites afin de programmer les prises de vue commandées par la Direction du renseignement militaire.
Le CNES vient de recevoir les listes de programmation à envoyer au satellite CSO. L'équipe mission a préparé les automatismes permettant de transformer les listes reçues en ordre élémentaire pour chacun des satellites. Les ingénieurs mission surveillent le bon déroulement des activités pour intervenir en cas de problème et ainsi maintenir un très haut niveau de disponibilité du système pour les utilisateurs. Les télécommandes sont prêtes. Pendant ce temps, l'équipe bord veille au grain. Son rôle, assurer la bonne santé des satellites. Elle réalise des activités permettant d'anticiper les problèmes sur les satellites afin de garantir leur fonctionnement et une disponibilité maximale pour les utilisateurs. En cas d'anomalie, elle mène les investigations pour identifier la cause et réaliser les opérations de remise en condition opérationnelle du satellite. En parallèle, l'équipe dynamique de vol vérifie les résultats de la détermination d'orbite qui calcule la trajectoire réelle du satellite. Si celle-ci s'éloigne trop de l'orbite nominale, alors l'équipe programme une manœuvre de correction d'orbite. La trajectoire réelle est utilisée pour surveiller les rapprochements avec les autres objets spatiaux. En cas de risque de collision, l'équipe programme une manœuvre d'évitement. Cette trajectoire est également utilisée pour piloter les stations au sol et la programmation des prises de vue. L'équipe sol est responsable du bon fonctionnement des moyens matériels et logiciels du centre de contrôle pour l'ensemble des métiers.
La propulsion est nominale.
La surveillance quotidienne des systèmes informatiques permet d'intervenir au plus vite dès qu'un incident est détecté. La moindre défaillance est traquée et corrigée en un temps record. Elle apporte également son expertise aux autres équipes pour tout besoin d'évolution de leur logiciel. Puis vient le moment fatidique.
Les paramètres à bord sont
Depuis le
nominaux.
centre d'opération du réseau CORE, les antennes prennent le relais. C'est le point névralgique à partir duquel elles sont pilotées pour émettre des télécommandes et recevoir les télémesures. La station d'Ossa Galicius est désormais connectée au satellite CSO en visibilité. Retour au CPCC. Maintenant que le satellite est connecté et positionné sur son orbite mission, le contrôleur supervise le bon déroulement des dernières activités. Tout se déroule comme prévu. Les télécommandes sont envoyées. La direction du renseignement militaire réceptionne les images à usage défense et les exploite pour assurer la sécurité du territoire. Quant aux images techniques, elles descendent vers le centre d'expertise du CNES pour être traitées par l'équipe qualité image. Radiométrie, géométrie et résolution des images sont affinées. Les images deviennent optimales. Ces performances seront suivies durant toute la durée de vie des satellites. Grâce à CSO-3, le troisième et dernier satellite CSO et ses nouvelles capacités, la précision atteint de nouveaux sommets. Images plus nettes, délai réduit, capacité décuplée, un atout stratégique inestimable pour la défense. Mission accomplie pour les équipes CSO du CNES.
La propulsion est nominale.
14 minutes into the flight, the rocket talks to us as it flies over. It communicates with the tracking stations. They collect the data and they send it here to what we call the CVI, or the Quick Look Telemetry team, who are at the Guiana Space Center. There they are, bottom right-hand side. He's telling us that everything's going normally, the Range Operations Manager. There they are. David, what are they doing?
So, yes, they are collecting the real-time data that the launcher is sending. This includes the status of the engine, the trajectory, the flight control. And they compare this live data from the rocket to what has been predicted. So this allows them to continuously analyze the launcher's behavior and to confirm that it is as expected.
Now, lots of people working across Europe on the rocket and the satellite. Let's hear from some of the team.
Trajectoire nominale, paramètres à bord nominaux.
Moi, je suis le Launch Campaign Operation Manager, donc le chef des opérations de lancement sur la campagne VA263. Fred est mon député sur cette campagne. mais ça n'a pas toujours été le cas.
Sur le premier vol Ariane-6, qui était le vol inaugural, qu'on appelait aussi FM1, j'étais Helcom sur la campagne et Nicolas était mon député.
Ce qu'il faut voir, c'est qu'on va échanger nos fonctions pendant tout le début de la phase IOC, l'Intermediate Operational Capability, de manière à ce que chaque fois l'un soit en titre et l'autre soit en deputy, et fasse en sorte qu'on profite de la campagne en cours pour déjà préparer le après et déjà préparer les optimisations et les réductions du cycle opérationnel de campagne en campagne. Voilà, donc c'est ça l'enjeu de cette phase un peu particulière qui est le début de la phase d'exploitation.
L'idée en fait d'être deux aussi sur Sénat, c'est des formes de continuité.
Trajectoire conforme à l'attendu,
du pilotage, aussi dans l'amélioration de nos process de pilotage, de notre organisation, mais aussi de notre montée en compétences et en maturité technique. Donc on a besoin aussi de ça, de cette continuité sur chaque vol, parce que le système en fait il est jeune aujourd'hui, donc on est en train de le faire grandir et il est évolutif et on a besoin d'être à deux pour assurer cette continuité de manière efficace et de manière dynamique.
Donc mon métier de directeur de mission satellite consiste à vérifier au préalable que le satellite est compatible du lanceur, donc des environnements à la fois mécaniques, électroniques, électromagnétiques, environnementaux, acoustiques, un large panel de métiers et de technicité pour valider la bonne interface et compatibilité du satellite avec le lanceur. Ici en Guyane, mon rôle de directeur de mission satellite consiste avec ArianeSpace à piloter la campagne de lancement du satellite jusqu'à la chronologie finale et la mise à poste par le lanceur.
Je travaille sur le projet depuis 2006. J'ai commencé par le pilotage des satellites. Ensuite, je me suis occupée de qualité image. J'ai bifurqué vers le suivi de l'instrument, donc de la charge utile fabriquée par Thales ArianeSpace's. Et depuis 2021, je suis responsable de l'ensemble du programme pour Airbus. Sur un projet de cette envergure, des centaines de personnes ont contribué, de la phase de conception à la phase de développement, puis de fabrication et finalement de tests, et tout ça dans nos locaux à Toulouse.
Le développement de l'instrument et de ses équipements a été réalisé par des équipes Thales ArianeSpace très expérimentées. Pour beaucoup, elles ont déjà travaillé sur Helios 1, Helios 2, Pléiade. Toutes les activités sont réalisées sur les sites de Thales ArianeSpace de Cannes, Toulouse, Aix-en-Provence pour Thales CSO. Nous avons actuellement une équipe qui est présente sur le site du CNES à Toulouse pour participer à la mise à poste et aller jusqu'à aux premières prises de vue visibles et infrarouges de notre instrument.
Pour ArianeSpace, je suis responsable production des adaptateurs. C'est une pièce mécanique qui sert d'interface entre le satellite et le lanceur. Mon travail consiste aussi à apporter une expertise technique lors des opérations d'intégration du satellite sur l'adaptateur et sur le lanceur, et ce, dans le but de garantir la bonne intégration du satellite sur le lanceur, son aptitude de vol, jusqu'à sa séparation. Ce qui est passionnant dans mon métier, c'est que je joue en fait le rôle d'adaptateur entre le monde du lanceur Ariane Group et le monde du satellite avec notre client CNES et le constructeur du satellite Airbus. Avec mes collègues d'ArianeSpace, notre travail est de faire rencontrer ces deux mondes pour garantir le succès de la mission.
Oh, incredible. David, they're your colleagues. It must...
It's colleagues and customers, both working hand in hand to make this a success.
Indeed, I think everyone can feel very proud. Right, coming up to the next major event, that will be the switching off of the Vinci engine. That's what it looks like. It's burning at the moment and has about 5 seconds left on the burn.
Première extinction Vinci.
And we have confirmation there that the engine has indeed switched off. So, the first major step now in reaching the desired orbit. We're coasting effectively now, David, without the engine. Why did we switch it off now?
Yes, well, it's a bit like a roller coaster. We have picked up speed. You can see on the curve that we have decreased a bit the altitude, and we have been picking up speed also because the Ariane 6 has been pushing us for over 20 minutes now. And we are at the bottom, and we will be climbing up using the speed that we have. In physical terms, we will be transforming the kinetic energy that the launcher has been giving us into potential energy, climbing higher.
We've got a question coming in on YouTube. Paul Graves is asking, was the air conditioning inside the fairing to keep the payload healthy?
Yes, the answer is yes, of course, while the satellite is sitting on the ground under the fairing, because we have heat and humidity here in French Guiana, we have constantly providing air conditioning to the satellite to keep it at the temperature that they require.
We're flying around at the moment on what we call an elliptical orbit. It's the shape of an oval. Imagine the Earth at one end of the oval, and our spacecraft, our rocket is effectively slingshotting close to Earth and then far away from Earth in its orbit.
Yes, that's right. At its closest point, what we call the perigee, the rocket is about 330 kilometers. That's where we are now. And at the farthest point, it's just over 750 kilometers. And it takes about 37 minutes to climb to this highest point. And once we get there, we will switch on the engine again to reach the targeted orbit.
He's telling us that the propulsion's normal, everything's going normally according to plan. Another question from Erwan, who has asked, why are there so many armed forces for this launch?
Well, in fact, the Guiana Space Center is Europe's spaceport, and as such, it is a strategic facility for Europe. Therefore, the center is constantly protected by the French Foreign Legion and the armed forces. But for today's launch, considering the nature of our passenger, there are additional forces that have been deployed to assure the security of the launch and the satellite. For example, we had some Rafale fighter jets that have been deployed around the launch site.
Yep, the Rafale, or Rafale in French, the French fighter jets, which I think Rafale means gust of wind in English.
That's right.
Yep. So, 22 minutes and 20 seconds. We are at an altitude of 328 kilometers and flying just under 8 kilometers per second. We are coasting without the engine right now. The teams at the French Space Agency, CNES, are eagerly waiting to take control of their satellite. And their mission control room, we saw them earlier, it's in Toulouse in France. Let's go over now to the project manager, Paul Arberet, and the team.
Et aussi de concentration en salle de contrôle principale que vous découvrez derrière moi, où se trouvent réunis les experts.
Good afternoon, everyone. We're all very focused here in the main control room that you can discover behind me, where our experts are together. They have designed the CSO system, so we have experts from the CNES, from Airbus, from Thales ArianeSpace, and for several weeks they are going to steer the operations, ensure that all of the equipment is working properly in order to carry out this mission. So let me give you a little bit of an explanation as to what will take place for this satellite as soon as we detect that it's been separated from the launcher. It's going to start an automated sequence. First of all, it's going to deploy its solar panels. It's going to carry out several maneuvers so that its solar panels are headed towards the sun and that its antennas are headed towards the ground, to keep in touch with experts here in Toulouse. So I've asked Jean-René and Camille Souchet to join me so that they can tell you a little bit more about their job. Jean-Renaud, you're an expert. You're an avionics and onboarded electronics architect. So you are going to follow all of the equipment and ensure that it's all working properly. And if it's not, you will come up with a diagnostic so that we can react accordingly. Once the satellite is in orbit, what do you exactly do to be able to react? We have many resources on board the satellite, as well as in the room with all of our experts, so whether they're CNES, Airbus, or TAS. And if we see that something went amiss, we are going to carry out a diagnosis in order to carry out to find out a backup system, so we can also change the equipment if needed, because our satellite has a lot of redundant equipment, so we can change the settings at any time if needed. So Jean-Renaud, you've been doing this job for over 30 years. You've done more than 10 launches. So how has your job evolved over the years? So it's always a very instructive job. Each launch teaches us a lot because there's
using a small thrust, two little thrusters mounted in the back side of the upper stage. This thrust is used to settle the propellants at the bottom of the tanks in order to make sure that the propellants are injected into the Vinci engine as expected.
Getting up close now to the next main event, which will be the switching on of the Vinci engine. Now, this is the animation. I was talking and I didn't hear what you said. Ah, good. There we have the second switching on confirmation of the Vinci upper stage engine, and he says that everything is going normally. It's a short boost, this one.
Yeah. Yes, it will be around 30 seconds.
And we have the confirmation there that we've switched the engine off. So that's good news. And of course, the teams who are relaying all the information, the tracking. Everything's going well. The tracking stations send the information from the rocket as it flies over to the quick look telemetry teams, or we call them the CVI team here. There they are, David. They are now tracking our rocket. What's the atmosphere like in there?
Well, there is a lot of adrenaline as they're all focusing on what they see on the screens. There are moments of tension during the critical phases, like the liftoff and the stage operations. But of course, a lot of relief when the rocket passes successfully all these different phases.
Indeed, it's a very dynamic. He's telling us everything's normal. Dynamic and high-pressure environment, but also incredibly rewarding because this small team is essential to the success of the mission. And actually, the range operations manager is listening into them on the comms loop, and they're giving the information for him to then call out to the whole base.
That's right.
So looking here at the animation images as we fly over Australia, we've had a few more questions coming in on the chats, lots of you messaging in. Diego wanted to know, David, what do you guys offer? So ArianeSpace, which is the company which operates the launches, what do you offer that other launch service providers don't?
Well, at ArianeSpace, we offer customized launch services to our customers. We work hand in hand with them in order to tailor our launch services to their needs, in order to be very precise on the needs of the customer. Here we see the teams in the CDL, the Launch Control Center, that have done all the preparation just before liftoff, and that, of course, are now relieved to have seen the launcher launching and starting its journey into space.
They do certainly look very, very happy, actually, at the way things are going so far. We've got another question here from Our Sky Heaven, who asks, when will we see an Ariane 6 4 version liftoff? Just a reminder that we've got two versions of Ariane 6. We've got a 2-booster version and a 4-booster version.
Right, and the 4-booster version we should have the first launch a bit later this year.
Look, we can see there the tracking station in that green dot on the southwest coast of Australia. The teams there tracking us right now. The space sector really is booming, I think it's fair to say, and one of the features of Ariane 6, of course, is its flexibility to deliver any type of satellite to any kind of orbit. And that really is important because there are so many different kinds of space missions, aren't there? From, connecting us all to the internet to going out and looking at other planets.
Yes, that's right. We have different types of satellites that Ariane 6 will launch in the coming years. Telecommunication satellites for telephone and TV. We have navigation satellites that everybody uses when they take their cars today. We have Earth observation satellites like the one we are launching today, but also for climate and weather forecast. And we have constellations of satellites that are also being launched and that are allowed to have internet coverage everywhere. And then we have more scientific missions and exploration missions. We have launched in the past with Ariane 5, and we will do it also with Ariane 6, missions to other planets, telescopes, and all kinds of missions that for which Ariane 6 can be used.
To what remains of our rocket, the upper stage, these upper stages job to deliver our satellite to the orbit that it needs to be delivered on in order for it to start its life. And our range operations manager is telling us that everything is going well. Got another question here, David, from Saudi 0001, who asks, how many contracts has ArianeSpace signed for Ariane 6?
Well, ArianeSpace has now contracts signed to launch 32 Ariane 6 in the coming years, so we are going to be quite busy covering different types of missions that I just mentioned. Just a few weeks ago, we signed 3 new contracts, one for Sentinel-1D for the Copernicus Earth Observation Program for the European Commission and ESA, which, by the way, will be launched a bit later this year. We'll sign the Galileo second generation, the first set of satellites, also for the European Commission, the European navigation satellites. And also we signed Plato, which is a space telescope, a space planet hunter for the European Space Agency Science Directorate, so a telescope that will search for extrasolar planets.
That's very exciting indeed. Planets around other stars, we're finding more and more of them. Right now, right-hand side of the screen, our altitude just under 800 kilometers above our planet. We've travelled 17,000 kilometers from the pad. It's slightly reducing because we're actually coming around the other side and getting closer to our pad. And if you look at the far side, 7.55 kilometers per second is our speed. That's per second, just under 8 kilometers per second as we fly, hurtle even, around our planet. And there we are, flying over southwestern Australia. We have a question from Gabin, who says, how have you managed to reduce the size of the boosters compared to Ariane 5? That was the previous rocket.
Yes, that's right. He's right. On Ariane 5, we had 240-ton solid propellant boosters. While on Ariane 6 today, we have 245-ton boosters. But in fact, on Ariane 6, we have introduced an additional modularity to adapt the performance of the launcher to the mission. So indeed, today we have less propellant than one we had on Ariane 5. But when we will launch the Ariane 64 version, we will have twice as much, so around 580 tons, and we will have even more propellant than what we had on Ariane 5.
Now, we are going to be injecting CSO-3, our satellite, which you can see attached to the front of the rocket there, in the animation. We're going to be launching ejecting it into what we call a sun-synchronous orbit. Just very briefly, can you explain what that actually means, David?
Yeah, it's an orbit that is synchronized with the movement of the Earth and the Sun in such way that we always pass over a place on Earth at the same local time, so that we have the same lighting on the places that we will be taking pictures of.
Very important, obviously, for the photography. So getting close now to what we call separation of the satellite. That is the process of ejecting our satellite into space. Our upper stage is orientating the satellite. It's a very precise series of maneuvers because we have to place our satellite in a very specific and precise location, if you like, a very precise orbit, in order for it to be able to carry on its job. Now, can we see New Norcia down there on the ground? There we go, just southwest Australia. So what's actually happening, David, up there now?
Yeah, so we're turning the launcher and the satellite in a precise way and putting it in a precise direction as requested by the satellite. And then once this is done, we will have the computer will send the separation command, and there will be springs that will gently push away the satellite. So we have now finished these orientation maneuvers, and the separation should take place in just
under a minute.
Yep.
Looking here at the animation of the predicted plan for what's happening up there in space. Always looks like it's happening very slowly, but of course we are travelling at just under 8 kilometers per second. About 25 seconds now to the separation of CSO-3 from the upper stage of the rocket.
Extinction APU.
The APU has been switched off, he's confirmed.
Séparation CSO-3.
From the upper stage and ejected into space. We are looking at some very happy faces here in the Mission Control Center and here in the Launch Control Center. A big round of applause from everybody who has worked so hard. This is a very, very good day.
Séparation CSO-3 confirmée par le client.
And it's been confirmed as well by ArianeSpace's customers. So that's great news, David.
Yes, very, very good news. So it's a great achievement. And congratulations to all the teams, to the French Ministry of Defense, CNES, Airbus, and Thales Alenia Space in charge of CSO-3. And of course to ArianeSpace, Ariane Group, CNES and ESA on the launcher side that have been working in preparing this launch.
I think a big slap on the back to everybody. I think everyone can feel very, very proud of the work they've done today. People giving each other congratulations here in the Mission Control Center. Of course, the job is just finishing for some, and it's just beginning for others, because the teams who we've been chatting with and meeting
Pilotage calme.
At the French Space Agency CNES Mission Control Center in Toulouse, taking on their baby now. And we're hoping now to go to the CEO of ArianeSpace, who is in the fishbowl, David Cavalloles.
Hi, Cathy. Hi, Cathy.
David, congratulations.
Yeah. Thank you.
Very good news.
Thank you. This is an absolute pleasure for me today to announce that ArianeSpace has successfully placed into orbit the CSO-3 satellite. And you know, I would like to deeply and to warmly thank our client, the French Defense Procurement and Technology Agency, the French Space Agency, the Space Command, and the Ministry of Armies. Of course, after CSO-1, CSO-2, now ArianeSpace has successfully placed into orbit the whole CSO system, and today here in Kourou we can say that thanks to Ariane 6, Europe and France have their own autonomous access to space back, and this is a great news.
It really is, isn't it? I mean, it's an important day for everyone, for so many people, David, and it's a very important day for ArianeSpace.
Yeah, absolutely. As you know, we have